Hi, my dear students. I'm going to continue from the question number 11. Just read along with me. 5 blocks have the same mass but different base areas. They all rest on a horizontal table. A graph is plotted to show the relationship between the pressure exerted on the table and the base area of the block. Which graph shows this relationship? Okay, the topic name here is pressure. Okay, so this is the solid pressure. I told there are three type of pressure: solid, liquid, and gas. Here the formula is force divided by area is equal to pressure. And the concept is here: force increases, pressure increases; area increases, pressure decreases. So this area and pressure is inversely proportional. The inversely proportional, this is directly proportional. This is not directly proportional, but it is area increases, pressure increases. So it is wrong. Here area increases, pressure decreases, but the line is straight, so it is wrong. Inversely proportional always have the line like this: a curved line, a downward, a negative curved line. So the option is D. Option is D. It's like this. Okay. How can we prove the inversely proportional? If area is doubled, pressure is halved. You can check the number. Here is 2, example. Here number 2, here number 4. So area is doubled and you draw a line to the pressure. You draw a line to the pressure. Okay, here is a pressure and here is area. Area is doubled from 2 to 4. Pressure is halved. So don't forget to explain this. The question is asked in the theory. How to prove inversely proportional? You have to say area is doubled, pressure is half. Okay, students, then we go for the next question. Number 12. A small emergency generator supplies 432 million joules of electrical energy is in 24 hours. What is the average power output of the generator? So the topic name is power, that is work, energy, and power. There will be one question. One or three questions, 2-3 questions will be there. Work, energy, and power. The formula for power is equal to energy over time. Okay. Here it is given electrical energy directly. The values are given here. So 432 million. So 1, 2, 3, 4, 5, 6 divided by time. Time must be in seconds. It is given in hours. So you have to convert 24 hours into seconds. So 60 multiplied by 60. Okay. If you divide, you will get the answer 5000 watts. Okay. You can check from your calculator. So next question number 13. A parachutist has opened his parachute and is falling to earth at a constant speed. This constant speed, always in MCQ question, this keyword helps us. What is the principal energy conversion taking place as he falls? Okay, where he is falling from the sky, so he has gravitational potential energy because he is more above the ground. As he has more height, he should have gravitational potential energy, right? Any object held above the ground which has kinetic gravitational potential energy, and that gravitational potential energy converted to, so these two options we have to think about. These two options, initially it is wrong because the initial energy is not kinetic. See, even though he is falling, the initial energy must be gravitational potential energy is being converted to other forms of energy. Since the speed is constant, the kinetic energy is constant, is not changing. Okay, here they ask conversion taking place. So the conversion energy, the GPE, is converting to heat energy since he is falling at a constant speed. So here the keyword is constant speed. Constant speed, kinetic energy is constant. Please don't forget, there is a constant speed, kinetic energy is constant. So GPE directly converted to heat energy. Question number 14. An ice cube has a mass of 7.5 gram. The ice cube is 0 degrees Celsius. Note this point, 0 degrees Celsius. Heat from the surrounding reaches the ice cube at average rate of 1.25 joule per second. Note this number. How long? Note this keyword. Does it take for all the ice cube to melt? Note this point. So here keywords are 0, melt, and melt is the keyword for you. Okay, so it is the specific latent heat. The topic is specific latent heat. It is in thermal physics. Okay, I write formula here since we don't have a space, so I write the formula here. E is equal to ml. This is the formula, latent heat of fusion, because it is melting, ice melting to water, liquid. So solid to liquid, it is known as latent heat of fusion. If it is from water to vapor, latent heat of vaporization. This LF value is given here. How much? Here you can read it, 333 joule per gram. So the mass in this calculation, we have to keep it in gram. It's very important. Already it is given in grams. Sometime you have to note it down. It is given in kilograms, should be converted to gram. Multiply by 1000. Here no unit conversion necessary. Okay, now energy is not given. See, energy is not given, so immediately students will substitute whatever the value is available. They will put here in the energy. It's not good, right? We have to just think, and we need the help of another formula, that is energy is equal to, the formula is energy is equal to PT, right? So in the place of energy, I write power multiplied by time, and LF is latent heat of fusion. Now I want to find how long does it take. Right? So time, actually I want to find the time. So here the mass LF, latent heat of fusion, divided by power. The numerator value, when we take it to the other side, the right side, it becomes denominator, right? Okay, later you substitute all the values. The mass value is here 7.5, latent heat of fusion is 333, divided by the power. Is power always, the unit is given in watts, right? So the watts is equal to joule per second. So 1.25 joule per second here is power, right? So you substitute, in the place of power you substitute 1.25 joule per second. How it becomes joule per second? Please, in the power formula is energy over time. Energy is measured by joules, division is per, time is measured in seconds. So joule per second equivalent, watts equivalent unit is joule per second. Both are equal, both are same, right? So here the answer is C. The answer is C. You can use calculator to do the question, right? Okay. And question number 15. The liquid in a puddle evaporates. Keyword for you, evaporation. So the topic name, thermal physics, evaporation, thermal physics evaporation, and this causes its temperature to change. How does the temperature of the liquid change and why? Okay, evaporation, the concept of evaporation is, if there is a temperature, higher temperature, higher the evaporation. On the top surface of molecule, what happens? It gains kinetic energy, break the bonds between the molecules and escape from the surface, right? Now for example, here is a puddle and temperature, that is heat energy, falls on it. So on the surface temperature is higher, so higher the temperature, the molecules gain heat energy, and it vibrates and move faster. As it gains and moving faster, it does work against the force of attraction between the molecules, and it breaks the bond and escape from the surface, and it evaporates. As it evaporates, it takes out the higher energetic, that means the heat molecules. The heat energy is going out, so it leaves lower energetic molecules behind the surface. Okay, so higher energetic molecules escapes, lower energetic molecules stay behind, which causes cooling. So what happened? Change the temperature, increase or decrease? So these two options are wrong, right? Because when there is evaporation, temperature decreases. These two options we have to look at. The reason, less energetic molecules leave the liquid. Less energetic molecules cannot leave. Always more energetic molecules leaves the liquid. More energetic molecules leave the liquid because it has more energy. It can escape from the surface, right? So when it escape, lower energetic molecules will decrease the temperature. So the option is B. Question number 15, B. Okay. And now question number 16. By looking at the picture, you would know this is the thermal expansion. This also heat and temperature, the thermal physics. This question is coming under the topic of expansion, thermal expansion. There is a bimetallic strip made from brass and iron, is used as a thermostat. Thermostat is the device we are using it in the automatic electrical equipments like iron box, air conditioner, refrigerator, and many other devices. It is automatically turn on and turn off the power, so we are using it, the thermostat. This bimetallic strip plays a very big role in the electrical equipments. Here you can see on the top of this bimetallic strip is brass, and the bottom is an iron, right? So the brass expands more than iron. That means you supply heat energy, we supply heat energy for the brass and iron equally. By gaining this heat energy, the brass expands more. If it expands more, the length of brass increases more than the iron, right? So on the top surface, this is the brass. The length here you see increases. The bottom length is less. It increases more. That's option is B. You can see your past paper, the diagram would be more clear because of this. I convert the file from PDF to PowerPoint, so the dimensions of the pictures are changed. Please just go through your past paper so you would know you would see the clear picture. Okay students, now we can go for the question number 17. This is a repeated question. Question number 16 is a repeated question. All the questions, most of the questions are repeated, so you need practice, more practice. Question number 17. This question: when a refrigerator is switched on for the first time, the air surrounding the ice box is cooled. First you check the picture. Here is ice box, that means a freezer compartment. What happens to the density of this air and to its position inside the refrigerator. What happens to the density of this air, right? What happens now? The density of air here around the ice box, it cools the air molecules here all the places that are completely filled with air. When it touches the ice box, this becomes more dense because the molecules go closer, right? The the molecules, the air molecules are far apart. As it is cooled, the molecules go closer, the molecules go closer together. So when it goes closer, all the molecules go closer because it is cooled. The density increases. The concept, more denser always sinks, right? So the more density air molecule sinks, and comparing on the top, the bottom air molecules are a little warmer, so it is less denser, will move up, it rises. So more density sinks, less density air rises, so here there will be convection. So the name of the topic is here convection. This is also a thermal physics, conduction, convection, radiation, that is the thermal heat energy transfer. The topic name is heat energy transfer. Okay, so what is the answer here? Density, the cold density, will it decrease or increase? It decreases, right? So what are the two options here? These are the two options we have. So density increases and sinks to the bottom, stays at the top. It is wrong because the more density always sinks, right? If we have a water and you put ice cube, it stays at the top. Why? Because the less density ice cube is, the density of ice cube is less than water, right? So it stays up. If you put iron, any coin, it sinks because the density is more, right? So the same concept, students. So the answer is here, C. Question number 18. Convex lenses are used in cameras and as magnifying glasses. Which type of image are formed? Okay, convex lens used in camera, magnifying glass, and as magnifying glass. So here is a fact. The camera always gets a real picture. So the virtual image is not there because what is the definition of real image? Image which can be formed on the screen, which can be formed onto the screen. What is formed on the screen? Images. Image which can be formed on the screen is real. So the camera pictures, we can get the image on the film and we can develop and we get the photo, right? So we have an image on the screen, so it is a real image. And magnifying glass, we are not getting any image using a what is the function of magnifying glass? To enlarge the image. So here the image is virtual because the image that cannot be formed onto the screen using the magnifying glass. So the right option is B. So this is the way, always try to cancel out two options, students. So the other two options we can decide. Is that clear? Question number 19. This is the topic waves. In the waves there are three topics. One is the sound wave and light and water wave. That is the ripple tank, reflection and diffraction, all those sound and light and electromagnetic waves. Okay, these are all the topics we have in the waves. So this is coming under waves, the light topic. Which diagram shows an example of longitudinal wave? This is not light topic, this wave common, and it's a basic waves. Longitudinal wave. Longitudinal wave is a spring pushes backward and forwards. Longitudinal waves has compression, the region of compression, a region of rarefaction. So here is the particles are closely packed and is a high pressure region, and here the particles are far apart. Here is the low pressure region, so C denotes compression, R denotes rarefaction. And here is a light is a transverse wave, and here is a crest, and here is a trough. Okay, the peak is called a crest, and this bottom, this called a trough. Here this is an example of transverse wave, and here is a water wave is also example of transverse wave. So right here is this a transverse wave, and light is also a transverse wave, and the motion of this spring is an example of longitudinal wave. It's just a demo teachers used to show the difference between the two waves, longitudinal and transverse. The name of the spring is called a slinky spring. For a demo, you would know, you would see the waves, the difference between the waves easily using slinky springs, a soft and flexible spring. Question number 20. A flash of lightning and the corresponding of sound of thunder are detected 6 seconds apart. That means whenever you see a lightning, at the instantaneously you can't hear the thunder. It takes a time delay. There will be some time delay, which depends on the distance the lightning appears. Here 6 seconds apart, a person hears the thunder sound after 6 seconds. A student calculates the lightning struck about 1800 meters away. On which assumption is the calculation based? This assumption is a very important question for the theory. The assumption is light reaches us almost instantaneously, but sound travels 300 meters per second. This is the answer. It's a fact, because the speed of sound is only 300, 330, 340 meters per second. It's just an approximate value. We don't have accurate value, because it depends on the temperature of air molecules and the density of air molecules, right? It does not affect the pressure of the air molecules. Okay, so the speed in our calculation, we can take any values if it is not given. If it is given, you have to use the same value given in the question paper. Okay, otherwise you can use 330, 340. Okay, no problem. The speed of light is 3 times 10 to the power 8 meter per second. This is the speed of light. Vc is a symbol for the speed of light through vacuum. 3 times 10 to the power 8 meter per second. And even through air, we are following the same value, approximate value, 3 times 10 to the power 8 meter per second, even though the value is not accurate. They are using approximately 3 times 10 to the power 8 meter per second for the vacuum and for the air, right? Okay, students. So other options, you see, light travels 300 meter per second. Wrong. Light travels 300 times faster. No, it is much more greater. The sound of the thunder was emitted 6 seconds after the flash. So it is not right answer, because the immediately at the same time the lightning and the sound is produced at the same time. Since the speed of sound is very small, unless it takes more time to reach. Okay, is that clear? Okay, students. And question number 21. Here this is a sound wave. Question number 20 is a sound wave. Okay, and this is electromagnetic waves, because you see, a hospital needs to sterilize medical equipment. Underline this word, is the keyword. Which electromagnetic waves could be used? Okay, now here, how many electromagnetic waves we have? We have some mnemonic word. You see, R, M, I, V, U, X, G. So you can remember, like, remember me, I am, Vera, your, X, girlfriend. Any name you can give, any name, like any lady name. Remember me, I am Vera, your ex-girlfriend. So here R represents radio and M represents micro, I infrared, V visible light, U X-ray, X gamma, X-ray, G gamma rays. Okay. Here you can write HW on the top of the radio wave. Write HW just like homework, right? I will tell what it is. Here, if it is H higher, it must be lower. W wavelength, higher wavelength and decreases to lower wavelength. All the higher wavelengths should have lower frequency and the other side must be higher frequency. So you need to by heart only memorize only HW on the top of R. That is HW means higher wavelength. Other side must be lower wavelength. So how do you compare radio wave and infrared? A radio wave is a higher wavelength, infrared is a lower wavelength. Comparing radio, infrared is a lower wavelength. Okay, if you compare X-ray and radio wave, X-ray is a lowest wavelength than the radio wave, right? Like that, but it is the highest frequency than the radio wave. Okay, students, and in this we should know the examples and applications, uses of all the waves. It's important, right? So radio wave, we are using this radio wave for the TV local transmission, not for the satellite. Microwave TV transmission to the satellite. Satellite is a keyword for microwave, don't forget. And another one, we used to cook vegetable, we used to cook bread using microwave oven. That oven is using microwave. So there are two important use. Normally they ask TV transmission. TV means signal transmitted to the satellite. Yeah, which wave is a carrier? Microwave carry TV signal to the satellite. Okay. Here is infrared. I denotes infrared. Infrared use of a burglar alarm. Another remote TV remote control in the burglar alarm. A security system, we are using infrared. Visible, just to enhance visibility. UV, ultraviolet, sterilizing medical equipment and to detect fake currency. If you have fake dollars, fake euro, fake pound, you can use ultraviolet radiation pass through the paper and then you can find the coordination of the note and the currency, and then you can easily find out if it is fake or original. X-ray to detect the crack in the metal pipe under the ground, and you can take the X-ray photograph to find out the fracture in the bones, because the X-ray can penetrate the flesh but it is stopped by the bone. So the backside of the bone, there will be a shadow on the photographic plate, and there will be due to this shadow you can see a spot, a white spot, white patches. So the doctor can identify a fracture or any other things whatever they want to screen, right? And gamma rays, again, it sterilize medical equipment and it cure cancer cell, like chemotherapy they are using gamma rays. So ultraviolet sterilize medical equipment, gamma rays sterilize medical equipment. Here infrared, I told it's a remote control and burglar security system we are using. Microwaves, TV signal to the satellite, radio waves, TV signal. Ultraviolet is the sterilizing medical equipment. Okay. And question number 22. Here, a student holds a sheet of paper with letters on it facing a plane mirror. Facing a plane mirror means here that this is important. This is facing this. So the which letter is closer? F is closer, and how it is it is like this, right? The first, this point here is the first point. Here this is backside, so backside, because the distance between the same point from the object to the mirror, mirror to the object is same. So when you draw, you will get like this. So which is the option? B is the option. If suppose you place at the bottom of the letter, here is a mirror. So how the letter, this will come like this, right? So the option also is here. You see, can you see the option C? Here it looks like this, right? So you have to be very careful actually where the mirror is placed. Okay, students? Okay, now question number, this is also a light, the topic, that is the waves, light topic, and this also a light topic, a refraction, and this topic light, reflection, refraction, right? Because the bending of light, the light travels and it bends, right? Okay, now if you see here the plastic, this is a plastic semicircular block, and here is the incident ray passing through, and here it is refracted. When a light passing through the air medium to the plastic medium, here the density of air and the density of plastic, if you see, for the light, the density, it feels easy through the air and it is difficult through the plastic, because the particles for the light energy is difficult when it is passing through plastic. So it is more denser optical medium. So through more denser optical medium, the speed of light is less. When it comes out, again it is passing through air medium, so it is easier to pass through. So the speed again will increase. So the speed outside 3 times 10 to the power 8, here also 3 times 10 to the power 8. But inside the speed is not 3 times 10 to the power 8, it is less, because the density of the plastic is high. Density means the optical density. What is optical density? The light, the device where the light can pass through, that's the optical device. So optical density is more higher, so the speed is reduced. So how do we find the speed? We have a name, a constant factor name. The name is n, the refractive index. Refractive index. We have a formula for the refractive index. N is equal to sine I divided by sine R. Okay, students. Here, always students have some confusion. Okay, I give you some. I just want to give you some, share some trick with you. I is an angle. You cannot take wherever it is. You have to be very careful when you write the value in the place of I. Here I is not an angle of incidence. Whenever you do this question, please remember these points, very important. I is not angle of incidence. In this case, it is an angle in the less denser medium. Angle from the less denser medium. Sorry. And here angle from more denser medium. Now see, here is 62. Please cancel the 62 at the beginning. Here this 45 you can cancel. The reason, this is not at all, it is not going to participate any of A and R, because it's not from the normal. We need an angle from the normal to the ray. The normal, here is the normal. You see this line is a normal. Normal to the ray 45, normal to the ray 28. Another trick is, at the top always you should have a bigger value. At the bottom always you should have a smaller value. Because I told more denser medium, here is inside more denser medium angle 28. This is the less denser medium angle 45. Just sine 45 divided by sine 28. Okay, the answer is C, 1.51. Use your calculator to find out the answer, students. Okay, Question number 24, the next page. Here you can see 24. This is static electricity or electrostatics. That is stationary. The charges are stationary. Two metal spheres P and Q are mounted. Here you see P and Q are mounted on insulating stands and are touching each other. The metal sphere P and Q touches each other at this point. You see, they are uncharged. Both of them are uncharged. That means positive and negative charges are equal and they cancel out each other. So it is uncharged. A positively charged metal sphere. Here is a positively charged metal sphere. When you bring positively charged metal sphere brought closer to P but does not touch it, this includes charges on P and Q. This includes charges on P and Q. The positively charged metal sphere is held in this position and the sphere Q is moved to the right. That means the sphere Q is moving to the right. That means they separate each apart. Separate from each other away from the sphere P. What are the signs of the induced charges on P? What are the induced charges on P and Q? And how do these charges compare? Okay, now you see, when you bring it closer, what happens is a positively charged. So here we have positive and negative. So the negative charges are accumulated at this side, that is the left side, right? This side, left side, by leaving positive charges, because the positive charges are a nucleus. In this topic we are not discussing about the nucleus because the positive charges cannot move because it is in the nucleus. So the electrons, it can move here and there because they have a property of the movement. When it is disturbed, they move. By what is the disturbance here? Because the induction. Okay, the positive charges are pulling the electrons from the sphere, so it does not transfer, just it come and accumulate this left side. And here the majority of the charges are positive, right? Because from here most of the electrons they have moved, right? So this side they have less number of electrons, so the majority are positive, so it becomes a positively charged this side, and here is negatively charged more, because more negative electrons means electrons are here accumulated, gathered, right? Okay, now what happens here, since it is a positive, immediately the electrons in this Q will neutralize the positive charges. They supply electrons to the positive and it try to neutralize the right side of P by supplying electrons from here. So as it supplies electron here, this side, it becomes the majority of positive charges are appeared in this side. So here this part, the touching each other, this part becomes neutral. So as it is moving apart, the Q becomes positively charged. Q becomes positively charged and P becomes negatively charged when they move apart. Then later you can remove the positively charged metal sphere. You can have here the negatively charged metal sphere P and positively charged metal sphere Q. So charge on P, negative. So you can cancel these two options, right? And we have to just analyze these two options. So charge on Q is positive. Okay. Sizes of the charges are equal or unequal. It is always equal, because when in the induction the charges are not transferred, the charges are there as it is, they just neutralize here and the remaining charges are here and then other remaining charges are here, so they are equal, always equal. In what do we say, in this electrostatics induction part, they ask this question as a common question. It's equal, the size of the charges are equal. Okay. Okay. Question number 25. Which properties make material suitable for use as a core in an electromagnet? Electromagnet, it is a topic, magnetism topic. Okay, difficult to magnetize and easy to demagnetize. We are using the electromagnet core. Always just memorize, core is iron. We should use iron as a core inside the electromagnet because it is a soft magnet, which means which can easily magnetize and easily demagnetize. Otherwise, for example, we use this magnet, electromagnet, to lift in the crane. In the crane, we use this electromagnet to lift the car. So if you are using a steel, suppose you are using a steel. Steel is a hard magnet, which is difficult to magnetize and difficult to demagnetize. Once it is magnetized and it is difficult to demagnetize. Now you pass the current, so the steel becomes magnet and it attracts the car. Now you have to dump the car in the other side. So when you stop the current, the steel will not drop the car down. So what happens here? The car will not be dropped. So it is a disadvantage with the steel because it is difficult to demagnetize. That's what I told. The iron is easy to magnetize and easy to demagnetize. So it is the suitable material as a core in the electromagnet. Memorize this. Iron is a core in the electromagnet. It is a repeated question. The three options are wrong, students. Okay, so we will discuss the other questions in the next video from 26 to 40. Hope you understand. If you have any doubts, please ask and then post your comments in the box, and then please support me and then subscribe, and don't forget to like and subscribe. Thank you very much, my dear students.